In the previous video, we saw how we can use center markings to identify pairs and triples to deduce information about a cell. We're now going to look at how we can use corner markings to do the same thing. I typically try to avoid using corner markings unless I can get it down to 2 cells for a specific digit in a box. At least for the puzzles at my skill level, I rarely find it useful to have more than that. When there are 2 corner markings, there are 2 basic configurations. They either line up in a row or column, or they don't. We will focus on situations where they do, as this gives us the most information. Let's look at the logic. Suppose we have 2 corner markings in a box that are lined up like this. And let's focus on the box. There must be a 4 in one of these 2 cells, and so we can't have a 4 in any of these other cells. But now let's focus on the column and repeat the statement. There must be a 4 in one of these 2 cells, so we can't have a 4 in any of these other cells. The logic works identically. Here's a more complex example. Let's focus on the digit 6. Pause the video and see if you can create a couple useful corner markings. While it's possible to put corner markings all over the place, it's only in box 9 that you can get down to just 2 in the box. But since these markings are in the same row, we can also eliminate 6s as a possibility from the rest of the row, and this leads to information in box 8. In fact, we see that the 6 must be in column 6 of row 7. Even though we don't know the exact location of the 6 in box 9, we know that it must be in row 9, and that is enough to draw the additional inference. Sometimes you only have enough information to get another set of corner markings, but that's still information that can be useful, and so I mark it there when there are only 2 possibilities. There's a way that corner markings combine to create center markings that is important to understand. When you have 2 corner markings for 2 digits contained in 2 cells, those corner markings become a center marking. In other words, you know that those 2 digits must be in those 2 cells in the final solution. To see why, suppose that were not the case. Let's say that we deduce the value of the cell to be something other than a 4 or a 7. Then the corner marking logic tells us that this cell must be both a 4 and a 7 at the same time, which is impossible. This means that the original cell must be either a 4 or a 7, and then the corner marking logic tells us that the other cell must be the other digit. By converting these to a center marked cell, we can remind ourselves of this observation and block all other digits from these 2 cells. This is an example of how we can stack multiple levels of logic on top of each other. While this isn't complicated, it can take some time to get comfortable with it, but the practice is kind of the point of doing logic puzzles. As you get practice solving puzzles, you'll develop a larger capacity for managing multiple layers of logic like this. The next video will demonstrate another technique that practices this.